Welcome back to spring semester. I know you've missed your video lectures, so let's get started. And we're going to learn about transcendental functions. It's a really ugly word that mainly just means exponential functions and logarithmic functions. So we're going to review a little bit about how to solve exponential equations and simplify exponential expressions. It's going to be a really short video lecture, and then we'll do some homework problems in class. So if we have an exponential equation, the variable is now in the exponent. Here's the variable. It's in the exponent. This is different from what we know about power functions. Now, we've dealt with exponents before where the variable was the base. Write that here. We have a base, and we have a base raised to an exponent. But before, in our polynomials, we have power terms. This is a power function because it is a base raised to a real number power. So in exponential functions, that relationship is different. Now our base is a real number, some real number, and our exponent is our variable. So when we are plugging in values of x, it's not going in the base of these terms, it's going as the exponent of these terms. So when it comes time for us to solve these kinds of functions, the solutions come a little bit differently for us. So let's look at this function here. We have 3 to the 2x plus 1. 2x plus 1 is a variable expression, and then minus 5 equals 4. And here's another one. 3 to the x plus 1 equals 9 to the x minus 2. So we can isolate terms. We go about solving these expressions or these equations just like we did before. You're going to do everything you can to isolate that variable x on one side of the equal sign and just have a real number on the other side of the equal sign. So here's the process by which we're going to do that. So here's an example. We have the first one here, 3 to the 2x plus 1 minus 5 equals 4. Well, the first thing we're going to do is just add 5 to both sides. That way, that's one step closer to isolating x by itself on one side of the equal sign. Now, what we're going to attempt to do, our process, is to get the same base on both sides of the equal sign. Because once we do that, then we can use math to simplify. So whatever number is over here, I want to be able to write it as a number that has a base of 3. Well, that's easy. We know 9 is equivalent to 3 squared. So this says isolate the exponential expression and rewrite the constant in terms of the same base. Set the exponents equal to each other. So once we've done that, we take the exponents of both expressions and set them equal to each other. Now, this doesn't explain why we drop the bases. We just know that we can drop the bases. For those of you that are curious, the mathematics behind it, and it is mathematics we're going to need to know in a future lesson, so I'm going to show you how we get from this step to this step. What we're doing is we're performing the same mathematical operation on both sides of the equal sign. And what we're introducing is the inverse of this base. What undoes an exponential expression, that's a logarithmic expression. So I won't write what logarithm we're using, but I'm taking the log of this side and I'm taking the log of this side. Well, I will show you. Log base 3 of 3 to the 2x plus 1. If I have the same base in my log as I do in my exponent, then those two operations are inverses. They undo each other and they map us back to our original input, and we can see the original input here was this math expression 2x plus 1. So that's what we did on the left hand side. So if we did that on the left hand side, as long as we'll do the same thing on the right hand side, the same mathematical operation, then the results will be equal to each other. So that's technically what we're doing, is we're using the inverse operation on these exponential functions so that we can set those exponents equal to each other. So like before, where we talked about, if we have the same thing in the numerator, the same thing in the denominator, then they just cancel and we drop them. Well, that's not necessarily true. What happens is they have a value of 1, and 1 times anything just gives us that thing, right? So even though in practicality it looks like just dropping the base, what we're doing is we're doing an inverse operation. We just don't write this step down yet, but we're going to need to know how to do that. We'll learn how to do that. So now we have an equation in x. Very easy to solve this equation. We're going to subtract 1 from both sides. We're going to divide 2 on both sides, and this is a true equation when x equals 1/2. So pretty simple to do. The hardest part sometimes is going to be taking that constant value. I have no idea what happened there. Let's try this again. Oop, there's what happened there. Okay, as I was saying before PowerPoint freaked out, the hardest thing to do sometimes is to write this constant in terms of the same base. Now this one was really straightforward and really easy to do, but we'll see sometimes that gets a little more complicated. So let's work this other expression. We'll work through it. And so if we start out with 3 raised to the x plus 1 equals 9 raised to the x minus 2, same process. We want to isolate the exponential expressions, and so we're going to write this in terms of the same base. We know that 9 is 3 squared. When we take this 2, when we raise a power to a power, we multiply those powers. So we'll have 2 times x minus 2, and you can see that gives us the result 2x minus 4. That's where they have this expression from. So all of those exponential rules are going to come into play too that we know from our power terms. So if we have the same base, we can use the same mathematical operation on both sides, which means we get to just set the exponents equal to each other and combine like terms. So minus x on both sides leaves x, plus 4 on both sides leaves x equals 5. So homework's going to be pretty straightforward. The hardest part, and we'll practice this in class, is sometimes turning this into the same base, but we'll get lots of practice on that. No worries. So that's it for the first lesson back. Come to class next time and we'll work some homework problems.